Welcome to this video, which is the first in a series of videos designed to help you warm up for this year's paper 2 on the IGCSE chemistry course. So what I've done is I've looked at this year's paper 1, and looked at topics that didn't come up, and I've put together a series of questions which weren't examined in the first paper. So let's get started. We're going to start with quite a nice easy question on atomic structure. Okay, so here we go, and we are looking at the element lithium, and we're asked to identify the particles A, B and C. And before doing any of these questions, I recommend actually pausing the video and doing the question first and then listening to how I go through it. So when looking at this, you'll be obviously spotting the nucleus is here, and then the electrons in the shell out there, and working out which one's which. Now obviously the ones around the outside are going to be the electrons, so particle E, the electrons. My writing is even worse than it ever has. This is a world record. This is the worst writing ever. Particle B and C, a little bit more difficult to work out, but you should be able to spot that there are 3 white dots here, 3 white dots and 4 grey dots, and as there are 3 electrons, that tells us that the 3 white dots are actually protons, because in a neutral atom you'll have an equal number of protons and electrons. So particle C is going to be protons, and particle B be neutrons. Now, I know my writing's terrible. For some reason the pen and the screen aren't quite aligned, so it's going to make it even more difficult for me, so you'll have to bear with me. What's the mass number of the atom in the diagram? Well, we're looking at the nucleus at this point, so what's in there? We've got 7 particles in there, each of them having an atomic mass of 1, so the answer is 7, and I'll just try and make that look obvious. Use the diagram to explain why this is in group 1, because there is 1 electron in the outer shell. So the group number is determined by the number of electrons in the outer shell, and here we've got 1. Final question, write a balanced equation for the reaction of sodium with chlorine. So we've got sodium, Na, and we've got Cl2, which is Cl2 here. Okay, now helpfully it tells us that it's Cl2. Other questions might not tell us it's Cl2, they might just say sodium reacts with chlorine. So you need to know that chlorine, which is in group 7, is a diatomic element, and obviously all the other elements in group 7 are also diatomic. So sodium reacts with Cl2 to form sodium chloride. Sodium is in group 1, chlorine is in group 7, so they both have a valency of 1, so that's NaCl, and we'll see here that we've got 2 chlorines here and only 1 here, so let's balance that up by putting a 2 here, and that means we've got 2 sodiums on the right hand side now, so I'm going to put a 2 here. Now that would have been worth probably 2 marks in the exam, maybe 3, but usually 3 if they've asked you for state symbols, and in this case sodium is a solid at room temperature, so that would have been solid. Chlorine, a green gas, and sodium chloride, when it forms, is actually a solid as well. So that concludes this first question. Right, so here we've got a question, well, it continues on sodium chloride. It's obviously used to manufacture these products here, and hopefully you should all know that that's done in an electrolysis cell, and the product which is used for water purification is chlorine. So that's A. Now, this part of the question concerns the difference between an atom and an ion. Now, chloride ions are Cl-. So chlorine is in group 7, and in order to complete its outer shell of electrons, it will gain 1 electron, which means the number of protons and neutrons stay the same, but the number of electrons increases by 1. So we'll have 17 protons, 18 neutrons and 18 electrons. Now, annoyingly, the question then goes back to asking about what happens in an atom. So what are the arrangement of the electrons there? Well, in the first shell we'll have 2, in the next shell we'll have 8, and in the next shell we'll have, well, let's just have a look, we've got 17 electrons, and thus far we've got 10, which means we need another 7 in that outer shell. And so if we have an ion, that means we put that extra electron in that outer shell, so we have 2, 8, 8. And the writing's getting slightly better. And hopefully by now you're warmed up and you're ready for a moles calculation. So here we have a moles calculation, and as soon as you see this down here, you're thinking this is going to involve reacting gases together. Now, what we're doing is we're taking zinc sulfide and we're roasting it in oxygen to produce zinc oxide and sulfur dioxide. And this question is made slightly more difficult because they've given the mass of zinc sulfide in kilograms. But that shouldn't make a huge difference. You should be happy to convert the kilograms into grams. So I would make that very visible on the question. I would write that in the box below, unlike where I've written it, and I would say that was 48,500 grams. So the first thing I would do is I would convert our mass into moles, because that's the one thing we know in this question. We've been given the mass of zinc sulfide. So moles, if we're dealing with mass, moles equals mass over RFM, and the mass is 48,500, and the RFM is the atomic masses of zinc sulfide added together. So zinc, they've told you, is 65, sulfur, they've told you, is 32, so 65 and 32 added together is 97. So 48,500 divided by 97 equals 500. And hopefully you're doing this alongside a calculator. And we'll then work out the moles. And if anything, I'm being sloppy here. I've not written that this is the moles of zinc sulfide. And it's really important that I show the examiner exactly the moles I'm working out. So this is the moles of zinc sulfide, and that comes to 500. Now, as we've now got the moles of zinc sulfide here, that could be used to tell us how many moles of zinc oxide we've got and how many moles of sulfur dioxide we've got. And if you look at the number at the front, this number here, the big number, 2, 2, 2. So if you had 2 moles of zinc sulfide, you'd make 2 moles of sulfur dioxide. 1 mole of zinc sulfide, 1 mole of sulfur dioxide. So we've got a 1-to-1 ratio. Now we didn't have 1 or 2 moles of zinc sulfide, we had 500. So we therefore have the same amount of SO2. So moles of SO2 is 500. And we're nearly done in the question, because we've got the moles of sulfur dioxide. We now need to convert that to volume. And we're told that 1 mole of a gas occupies 24 decimeters cubed. So if we had 1 mole of SO2, it would occupy 24 decimeters cubed. We haven't got 1 mole, we've got 500 moles. So it would occupy 500 times the volume of that. So the volume equals moles times 24. So we've got 500 times 24, and that equals, just type it into your calculator, 12,000 decimeters cubed. And that's where I'm going to pause the first part of this video.